Greetings. Today we are going to present about our data mining project using the medical dataset. First of all, we need to open the enterprise miner software to do our model. So first we go uh, and open our SAS enterprise miner. This is our SAS software. Then we go to the solution. Then we click analyze and we select the enterprise miner. So now we are going to do a new diagram. So we rename the diagram. We name our group project as medical. Okay. Now we take the node input data source. We input our data into the SAS software. Then we select the source data. We go to the end data file. Then we take the medical data set. So now the medical data set in our SAS enterprise. Then we change our metadata sample. We use complete data example. Then we click the OK. Now we save the changes. Yes. Now we see here we got our medical data set into our model. We open it again and we change the variables. Here the status will be the target. That cost will be rejected. Age is rejected too. And age of death is rejected. Then we save all the changes. Okay. Now we insert the data partitioning node. So we connect M data to the data partitioning node. Now we open the data partitioning. We set the training data set at 70%. We no need to do the validation and we need 30% for testing data set. We use sample random method here. Then we save the changes. Now we add a new node. Here we are going to enter the replacement node. This replacement node is useful for finding the missing values in the dataset. Okay, we connect the data partitioning node to the replacement node. We open it. Okay, here we find there are variables which got the missing values, so we replace the missing values using the mean value from the data. Okay, we no need to change anything here. Then we add another new node, which is the transform variable. Okay, we connect the replacement node and transform variable node. We open it. Okay, here is in this node the output set is using the training data set, the 70% data. And here we no need to change anything. So next we are going to do the regression model. So we connect the transform variable node to the regression model. So here in regression model, we open it and we find some of the variables are no need to be used. Here we go to the selection method. We change the method to stepwise and we change the criteria to cross validation with classification. Then we go to the model options. We change to logistic regression. We are going to analyze the logistic regression for our sample data. Then we save the changes. See here the model name. We can change the name to medic data. And we click OK. See, now we run our regression model. Okay, since we calculating the result. Okay. Yes. Okay. We get our graph. So this is the estimate for our data. So we go to the statistic. Okay. We find that the misclassification rate for training is 0.253 and for testing is 0.256. Okay. You can save it. So now we are going to do the network neural network. So we add the neural network node to our model. We connect the transform variable and the neural network node. So then we open the neural network node. Okay. Now we run our neural network. This is the result for our neural network. Okay. Then we add the three nodes into our model. We add three nodes here because we are going to do the two split and three split network. So okay, we connect the three node with the data partitioning node. Then lastly, we enter the assessment node here. We connect all the regression, neural network, and the 2 split tree and 3 split tree into the assessment node. This assessment node is for comparison. Then we go to open our tree diagram. So now we have to change the maximum number of branches from the node. Here set is 2 and maximum depth of tree is 6. So this is 2 split. Then the next one, we are going to set it into 3 split. We change this one to 3 and the maximum depth of tree is 9. We save it. Now we can run our model. We run for the tree Sqit. Okay, now we done with our regression model, neural network model, and two Sqit and three Sqit 3. Now we can view our result in the assessment note. Okay, here we can see the result for the test misclassification rate. The last one is the regression is 0.25, and it shows the lowest misclassification rate, and regression model is the best model for our project. Now we are going to view our tree. We open the tree node. We close it. We run it again. We find that leaf is 14 leaves. And we go to the view. We view the tree. This is our tree diagram. And then we view the completing Sqit. In the completing Sqit, there are three variables has the highest log width, which is age at start, systolic, and BP status, so the highest rate compared to others. Okay, now we view the next tree diagram. We run it. We see that the leaf is increased to 21, and now we view the tree. This is the tree diagram, and we view the competing splits. Here the rate of the three variables is increased more. You can see that age at start is the log width is 1 to 5.49, systolic is 66.8, and BP status is 50.8. This tree is the best for our data. Okay, so we are going to insert another node here. The inside node is entered to our model. This is for just view the result diagrams to connect with the end data node. Okay, this is the full model for our project for the medical data set. We complete our model rule. That's all. Thank you.